Hey everyone! Ever wonder how AI can untangle the messy, complex web of relationships in data? Like how people connect in social networks, or how proteins interact in your body. Today, we're breaking down a game-changing tool called DHG-Bench, which is helping scientists test and improve hypergraph neural networks, AI models that go way beyond regular graphs to capture real-world complexity. Let's dive in. So what's a hypergraph? Think of a regular graph as a network of pairs, like friends on a social media platform. But real life isn't just one-on-one connections. Imagine a group project where multiple people collaborate, or a research paper with several authors. These are higher-order interactions, and that's where hypergraphs shine. In a hypergraph, a single, hyperreg can link multiple nodes at once, like a group chat where one message affects everyone. This makes them perfect for modeling complex systems, from academic collaborations to e-commerce networks. But here's the problem. Traditional AI models like graph neural networks, HNNs, are built for pairwise connections. They miss the bigger picture when it comes to group dynamics. That's where hypergraph neural networks, HNNs, come in. They're designed to learn from these multi-way relationships. But without a standardized way to test them, it's hard to know which HNNs are actually effective. Enter DHG-Bench, the first all-in-one testing ground for HNNs. Think of it as a lab where researchers can plug in their algorithms, run experiments, and see how they stack up. It's got 20 diverse datasets, from academic networks to e-commerce platforms, and 16 state-of-the-art HNN algorithms. But it's not just about quantity, it's about quality. The benchmark evaluates HNNs across 4 key areas. 1. Effectiveness. Can they solve tasks like predicting relationships or classifying groups? 2. Efficiency. How fast and resource-friendly are they? 3. Robustness. Can they handle messy, incomplete data? 4. Fairness. Do they treat all groups equally or do biases creep in? The results. HNNs show promise, but they're not perfect. Some struggle with scalability, like trying to handle a massive dataset and crashing. Others have blind spots in fairness. For example, algorithms might perform differently for users of different demographics, which is a big deal in real-world applications. But there's hope. The study highlights methods like TFHNN, which balances speed and accuracy by decoupling message passing from training. And the best part? DHG-Bench is open source, so anyone can use it to test ideas or improve models. So why does this matter? As AI becomes more woven into our lives, whether it's personalized recommendations or medical diagnostics, we need tools that can handle the complexity of real-world data. DHG-Bench is a major leap forward, offering a standardized way to push hypergraph learning to new heights. If you're curious to explore further, check the link in the description to access DHG-Bench. And if you enjoyed this deep dive, hit subscribe for more insights into the future of AI. Stay curious, and I'll see you next time. Ever tried comparing apples to oranges? That's basically what researchers were doing before DHG-Bench came along. Different studies tested AI models in completely different ways, like measuring a marathon with a ruler one day and a tape measure the next. Results? Chaos. How do you know which AI is actually better if the rules keep changing? DHG-Bench is the ultimate AI fitness trainer. It doesn't just check if a model can run accuracy, it does a full-body scan, how fast it works, efficiency, if it's biased, fairness, and whether it holds up under pressure, robustness. It's testing AI models on real-world challenges, like analyzing complex networks or solving problems with limited data. It's not just a quick checkup, it's a deep dive into what makes AI truly reliable. But here's the kicker. Right now, DHG-Bench is focused on semi-supervised learning, where AI gets some guidance, like a chef with a recipe outline but figuring out the rest on their own. But in the real world, recipes are rare. Future versions will embrace self-supervised learning, where AI learns by watching and exploring, like a kid learning to cook by watching YouTube instead of getting step-by-step instructions. Why does this matter? Because benchmarks like DHG-Bench aren't just about bragging rights. They're about building AI that's not just smart, but fair, adaptable, and trustworthy. Next time you hear about an AI breakthrough, remember, behind the scenes, tools like DHG-Bench are working hard to make sure those breakthroughs are built on solid ground. Stay curious and let's keep unlocking the future of AI together.